circle. Providing you 3 points of a circle. After you define the equation of circle, you have to set up in general form x squared plus y squared plus dx plus dy plus f equals to 0. And there are 3 unknowns df. Am I right? Am I right? Okay, and then you have actually a way that can help you to find the solution of DEF systematically. This is the way. Okay? Of course, when you look at the numerator, we can do what we do similarly, but in 2 by 2. By replacing jk with this jkl, and you can see that the expressions follow. Check. Isn't it correct? Okay? Isn't it correct? Okay, and let's also check y. If I replace it and I make a new rule of Cyrus, those 6 terms can be generated this way. Please check. If no problem, finally, Z. Okay? And here are the 6 cases that was accompanied by this. You may also check this final solution for Z. Isn't it correct? Okay, so now we can extend because we can find solution of a system of equation in a systematic way. So we can give our solution in that way if we define what this absolute value sign means here. Of course, now we call this determinant, not absolute value. We call this determinant. Is that clear? Okay, so fine. These are the denominator, and these are correspondingly the numerator of the 3 unknowns. Okay? So you may think of, then can we extend to a 4 by 4 or even higher form? Can we? Right? If you study mathematics in university, maybe you will handle 4 by 4 or even higher, right? Degree 4, degree 5, degree more, right? Okay, but I think those computations should rely on computer, right? Because they treat all these in a systematic way. Ultimately, want the computers to help because computer follow rules to calculate, right? And that's why it extends our human capability in handling very complex, complicated situation involving order n, for example. If order is 100, we have to solve a system of 100 unknown, right? Manually, right? Because you take a long time to do so, but for computer, a few seconds then can perform, especially for the supercomputer, right? Okay, so, but of course, in M2, we only handle this, and we don't want to know some theory underprinting this determinant. Okay? So, the first material, the first topics under determinant is the evaluation of this, right? So, very easy. So, that was the way, a general approach in evaluate. Evaluate means finding the value. If I gave you the values of A to I, can you help me to find the value without using calculator? Of course, those values was not large. Okay, right. So remember the rule that was set by the rule of Cyrus, and 3 positive terms, and then another 3 positive, and then another 3 negative terms. Okay. Or look at this. Now, let me tell you the truth. Now, in a 4 by 4 case, maybe you will think of, well, then how to expand? Because you know that in 2 by 2 case, we only have 2 arrows, right? In 3 by 3 case, we have altogether 6 arrows, and we have to define in a new perspective, right? What about 4 by 4? Are we going to generate another new rule in expanding the value of this determinant? And mathematician provide us another answer, right? Which is not, right? Which is not. They can even find some pattern that can carry throughout for order to be higher. Let's say if there is a 5 by 5 case, 5 by 5 determinants, or even 6 by 6 determinants, they will follow the same rule. And here is the investigation. Please look at that. I'm offering you, apart from rule of Cyrus, a new method of evaluation. And this new method can carry through even more higher order determinants. Okay? So let's take a look at this. EI, if we combine with the fifth term, and then BFG combined with the last term, and then of course the final CDH combined with this. And can you see among the two terms, consecutive terms, there are some common factor? Let's take a look at first. What is the common factor among these two? Now, these are all come from rule of Cyrus, but I'm trying to rearrange them. See if there are linkage between the 3 by 3 and 2 by 2, so as to find a general rule for that. Can you find what is the common factor of the first two terms? Loudly so that they can hear. A. Okay, fine. A. And what about the second two rows? B. And then Rachel, what is the final two? C. So can we take common factors out like this? Yes or no? Yes, okay. So what is then, can you see that? Could it be a possible arrangement of a 2 by 2 determinants? Can you see that? Here's that. Is it a 2 by 2 now? EIHF. EIHF. Oh, is a little determinant 2 by 2 determinants here. Can you see that? And what about ID, the second term? B times ID minus FG. ID, FG, another, right? Another, right? But bear in mind that this part is negative. So somehow you have to determine negative and positive. Is that okay? It's interesting, right? And C, DHGE, DHGE. So all these little 2 by 2 determinants using the second and third row to generate, where the common factor is actually coming from the first row. Okay? So could we set this as a general rule of expanding a 3 by 3 determinant? Yes, right? Okay? So I'm using coefficient in the first row and help the determinants of the remaining two rows in order to form a new expansion for it. Apart from the rule of Cyrus, we are generating another rule. But this rule highly link up with what we define by 2 by 2. Right? We're trying to make link between 3 by 3, 2 by 2. Rule of Cyrus doesn't tell me anything about 2 by 2, right? That is only a new rule. It is, of course, accurate in expanding the value, but not a general approach in looking at the relationship. Now we can see how they relate to a 2 by 2 cases. Okay, now that was what I tried to tell you. Okay, this is not rule of Cyrus, but the general rule making a 3 by 3 determinant in terms of 2 by 2. So what were you expecting then? In 4-5, although we don't need to learn 4 by 4, but what will you expect to do then? A 4 by 4 case could be in terms of 3 by 3. As long as we know how to find 3 by 3, then 4 by 4 could be in terms of 3 by 3 in the same way. Right? Of course, we won't talk about this. But if you are interested, I can go through that, go through with you with some examples. Don't worry. Okay? So here is what I generated first time. Can you see that? If I choose this A, I will just ignore the row and column governing A and cut out these two parts remaining are determined. We call this cofactor. This part is called the cofactor of A. Right? Okay? Okay? And then the next, if I choose B along the row, I choose B. And we cut out what B, the row and the column that B carries. We rename the 2 by 2 determinant. And that was the cofactor of B. Of course, the cofactor should also include the negative sign. I will tell you how to determine positive and negative later on. Okay? And then finally, same. And that part is the cofactor of C. Is that okay? Is that okay? Now, don't limit yourself. Mathematicians don't limit themselves to expand in such a way. Let's take a look at other approach. Same expressions from rule of Cyrus, but the arrangement will be different. Now this time, the first one, the fifth one, same. And then you can see that we are trying to use the second one and the last one this time. The third one and the last one. And the second and the fourth. See if you can also see common factor from consecutive terms. For these two, again, A, the second group, D, and then G. A, D, G. Can you see that A, D, G is coming from, not from column, but not from row, but from column, right? Okay? So, after arrangement, can you see that? After arrangement, you can see that this is EIFA. EIHF. EIHF, right? Since we choose this column, so the cofactor found, or the remaining part found, is actually coming from the second two columns. Right? Can you see that D, and then that was IB and CH, IB, CH, right? And then G, EF, EC. G, we cut out these two, and then EF, EC, right? So mathematicians try to find or look for rules, and that was their discovery. Is it incorrect? If I choose A, cofactors of A, right? D times cofactors of B. This time negative, okay? You will see a pattern of some alternative things found. One positive and the next is negative, and then the next is positive again. Right? Okay? And then G, positive. Okay? So, that was the approach. If I evaluate, then we're choosing plus, negative, plus here. Okay? Are these the only two rules that we can expand determinant? Think about it. Make a guess. Are these the only two approaches? Taking the first row and taking the first column, and we can generate this one? No. Whatever. Right. We can do another arrangement like BFG, IDB, and then AEI, right? GEC, and then CDH, HFA. Can you see that? It's 6 terms. Right? And then after that, we take our common factor. This time you see, I take common factor from the first two groups is negative B, and then E, and then negative again. And you see positive, negative, positive, negative. What is VEH here? VEH here is the second column. You see that? So, can I expand it this way then? I think we all agree. And then finally, you find another rule. Okay? But this is not new, actually. You can see that. This is not new. Now, since I have taken B already, and you see the cofactor of B is actually negative of this small 2 by 2 determinants. It's negative, right? Because the position of B is negative. Right? And then G, again, E. I'm taking out them, and then the remaining determinants is A, C, G, I. Right? And carry positive. And finally, H. If I cross out the column and row of H, that remains a 2 by 2 determinants A, C, D, F. And the cofactor include negative sign for this. Okay? So, that was the case. Right? So you know that some of the cofactor carries positive and some of the cofactors carry negative, right? Is that the only three ways? After this, I think you know that could be more others, right? That was G, H, I this time. I carry the last row to expand, right? So actually, you can take whatever row or whatever column values to generate this determinant. And this rule carry for all. And even in the case of 4x4 or even higher determinants, right? Let me re-emphasize again, we only need to handle 3x3, don't worry about this, okay? 4x4 university, okay? That was the case. So you can see that now we can make our rules now like this. Now the signs of expanding form are determined by the following diagram. Here you can see that the negative are all carried from here. Okay? Now interestingly, I will tell you there are some notation. You can see from my notes the elements inside now. These are not altogether 9 elements in this 3x3 determinants. Okay, so we call this a general notation for this part is error. This is A11, right? 11 means first one means first column, first row. First row, first column. And this is A12, right? This is A12, first row, second column, right? This is A13, first row, third column. And this is A21, right? Second row, first column.